So I would like to hand the floor over to the missionary executive from Johns Hopkins of Space Exploration Sector, Dr. Jason Kalirai, who will present a few words from us at APL and then hand the floor over to Jim Ryder for his talk. So Jason, welcome.
Well, thank you very much, Rachel, and good morning and welcome everybody, and thank you to our distinguished guests for having us here at Bowie State University, and also for all of your inspirational remarks this morning. It's a real pleasure to be hosting this conference here and to partner with Bowie State University, and also to be doing it with so many people that are in person. I'm really looking forward to a couple days of very rich interactions through this meeting. So thank you all very much. The growth in the Lunar Surface Innovation Consortium over the last 2 years has been incredible, and so I know we have a lot of new partners and new experts that are helping to contribute to the vision of building a sustained presence on the moon. And I just wanted to take a few minutes and say a few words about the Johns Hopkins University Applied Physics Lab and kind of put this program in context with some of the work that we do. So first, we're located right down the road. We're in Laurel, Maryland, and we're about 30 minutes west of here in Howard County. It's a campus where we have about 8,000 staff members, and we are a university-affiliated research center, and we provide critical capabilities to the U.S. government, many different agencies in the U.S. government, including agencies within the Department of Defense. And as Rachel said, I'm the missionary executive for the Civil Space Program at APL, which is a major part of the overall APL work that we do. A big piece of the Civil Space Program, almost in the entire part of the Civil Space Program at APL, is working hand in glove with NASA. And a lot of what we do is work with NASA's Science Mission Directorate. And the framework that we have at APL is a science-driven organization, but designed to advance technologies, build technologies, and build highly complex missions and instruments that we can then fly across our solar system and expand scientific discovery. And so examples of programs that we've built for NASA include, for example, the New Horizons mission. That was a mission that we sent to Pluto. And it captured beautiful images and beautiful scientific data of Pluto and presented the characters of that world to our world. And also then flew beyond Pluto into the asteroid belt and into the Kuiper belt and is studying the fossils of our solar system. Another mission that we just launched 3 years ago was called Parker Solar Probe. This is the fastest human-made object ever. It's traveling at more than 300,000 miles per hour. And it's a mission that's literally flying through the atmosphere of our sun to understand how our sun works. It's been a very successful mission. More than 500 research papers have been published by the community already. We're developing a program right now in partnership with the Jet Propulsion Lab, JPL, in Pasadena, California, called Europa Clipper. This is a giant flagship mission that's visiting Jupiter's moon Europa, which has a subsurface ocean, to study habitability on that moon. And we were also recently selected for 2 missions. One is called IMAP, the Interstellar Mapping and Acceleration Probe, which is a heliophysics mission to study our heliosphere, and Dragonfly, which is a nuclear-powered quadcopter the size of your car that's going to fly around on Saturn's moon, Titan, to study habitability and the prebiotic chemistry of Titan. So lots and lots of exciting programs in partnership with NASA. And the final one that I'll mention is our next launch. In 3 weeks, we're going to be launching a program from the Vandenberg Space Force Base on a Falcon 9 rocket called DART, the Double Asteroid Redirection Test. And this is NASA's first planetary defense mission. We're going to take a spacecraft, we're going to accelerate it to 15,000 miles per hour, and we're going to hit an asteroid, and we're going to move the orbit of that asteroid as a part of this program. So it's a very exciting program. If you haven't heard of DART, you're going to hear a lot more about it in the next couple of weeks as we get ready to launch. But of course, we're not here to talk about the work that we do with the Science Mission Directorate. We're here to talk about the work that we're doing with the Space Technology Mission Directorate. And this has been a very, very exciting partnership for us. it's a little different from most of the work that we do, because we're in a role at APL to be kind of a systems integrator and bring together the best and brightest from across the nation to help address some of the critical challenges that Pam and others have spoken about earlier today. And the program has been very successful thanks to the leadership of Rachel and Ben Bussey and Brenda Clyde and others that are in the room. And it's been incredible to see the progress that's being made in each of the focus groups to address those critical needs. I was with Pam last week in Dubai, where we had the International Astronautical Congress. And every day of the meeting, there were sessions and panels on the topic of the sustained presence on the lunar surface and the maturation of the critical technologies that are needed to achieve that. And so I want to say to everybody here that's on virtually and in person that your work is being recognized on an international stage and was referenced throughout this meeting. And so it's been a very, very successful kickoff and a very successful project. So congratulations to everybody. I also want to say that there's kind of this new sense of urgency, I think, in the work that we're doing, right? Because what the boldest pursuit that is happening at NASA right now is, of course, the Artemis program. And we've been talking about the Artemis program for many years now. And we are now 4 months away from Artemis 1 launching, right? It's right around the corner. The rocket, the SLS, we've been talking about SLS for many years. It's fully stacked up. Orion is sitting on top of it, and we're about to launch. And so this is a huge milestone that's going to bring even more visibility, even more focus and attention on the work that we're doing here to build that infrastructure that allows that program to be successful. So again, I want to thank everybody for coming here, and I think we're all looking forward to a wonderful, wonderful conference here. So with that, I want to introduce our first speaker, Jim Ryder. Jim doesn't need any introduction. Everybody knows him very well. Jim is the Associate Administrator for the Space Technology Mission Directorate. He's been in that role for about 2 years, a little more than 2 years. Before that, he was the Acting Associate Administrator. Jim has been a tireless advocate for technology development at NASA and has been a tireless advocate with his support for both the Lunar Surface Innovation Initiative as well as the Lunar Surface Innovation Consortium. In fact, last night, I was at the Capitol Hill Club in Washington, D.C., sitting on a panel talking about Moon, Mars, and beyond. And I was poking around at their agenda, and next week or maybe the week after, Jim is the speaker talking about the work that STMD does. So Jim, thank you for everything that you're doing. So I will keep it short and close with that, because I know everybody wants to hear from Jim.